Okay, hopefully a quick refresher on how to find the inverse. So here's the basic setup. Rewrite as y is equal. Typically you'll have an f of x. Write it as y is equal. Swap the x and the y's from the function. Solve for y. Then once you get y by itself, rewrite it as y to the raised negative 1 or f to the raised negative 1 of x. And graphically, this is how you know functions are inverses. If you have one graph that looks like this, and the other graph looks like this, and if you imagine that diagonal 45-degree angle, if you could fold these two over and the graphs would lay on top of each other, that's how you know graphically that functions are inverses of each other. Okay, so let's go ahead and get started. Find the inverse of each function. So the first thing we're going to do is rewrite this as y is equal. Right there, f of n, I'm going to put y, and I just rewrote it. Now, we're going to swap the y and the n. So all I did was put in where the y was and y where the n was. And now we're just going to start solving. So we get rid of the outside number first. We're going to add 3 to both sides. And then we're going to simplify that. And then the undoing of something to the 5th power is something to the 5th root. When you take the 5th root, that goes away. And now what we have on the right side is y plus 2. So we're going to subtract 2 on both sides. And once you subtract the 2, you're going to have a y by itself. So that's when we do the last step. Rewrite as y to the raised negative 1, or in this case, I probably should have written that as f to the raised negative 1 of n. As your instructor, I would accept probably either, since we start doing this. Anyway, so that's it on that one. Let's do another one. We're going to write as y is equal. We're going to swap the x's and the y's. All I did was swap those and then start solving. I'm going to add 2. And then that leaves 3y. Then we're going to divide both sides by 3. When you divide by 3, you can either do it like this, or you can put one divide sign and do that. And depending on who your instructor is, I'll accept either way. Notice I did it, I left it like this. If you had to graph this, if your teacher wanted you graphing this as well, it probably would be easier to put x over 3, which means 1/3 x, plus 2/3 is equal to y, because now you know, oh, if you're to graph that, you're going to start up here at 2/3, and you're going to go up 1 over 3, and you know the graph will end up looking about like that. All right, let's do one more. So again, we're going to rewrite. We're going to swap the x's and the y's. This one's trickier because the y is down in the denominator, but if you do it step by step, so we're going to get rid of this first. Then I'm going to show you a trick how you can do 2 steps in one. So now we have x subtract 1 over here. Notice there is a negative 1 on the outside right there. We could then divide both sides by negative 1. But what I'm going to show you, I'm going to flip both sides because now we have a fraction over a fraction. So I did that, and now look, I have this negative 1, but if I think about that as negative 1/2 times y subtract 2, I can just multiply both sides by negative 2. That takes care of the negative sign, and it takes care of the 2. So let me reiterate. I see that there's a negative sign, and that's a 2 in the denominator. I'm going to think about this as negative 1/2. So I'm going to multiply the inverse of negative 1/2 is negative 2. When I multiply this, a negative times negative is positive. Those cancel. I'm going to multiply that side by negative 2. All right, and now the very last step, we're going to add 2 to both sides. So we have, this is the final inverse, and then I put to the raised negative 1, or we could have put h to the raised negative 1 of x. I think most teachers will accept both answers. All right, that's it.